So all a polyprotic acid is something that has multiple H pluses on the front of it. And so if you take a look at H2CO3, it clearly has two of these H pluses. And when they dissociate, remember, dissociate is just a fancy way of saying leaves. So if you have two hydrogens in the front, that means that the hydrogens are going to leave one at a time. So the first hydrogen is going to go, and the way we keep our problems from becoming insane is we do all of our math with getting rid of the first hydrogen completely before the second hydrogen starts to leave, because that would make our problems really challenging. Now, they ask us in this problem just to write the balanced chemical equations for the sequence of reactions, and I love how they give us four spaces here, but in the reality, there's just two hydrogens we have to pull off. And this is one of the really cool things about understanding that whenever you do a Ka expression, you're throwing an acid into water, and a Kb expression, you're throwing a base into water, is that if you have an acid, you throw it in water, and you see what happens when the water grabs a hydrogen off. So we're going to start off here in this first spot and write H2CO3, aqueous, because we're dissolving in water. We're going to throw it into water, and what we know that water is going to do is that water is going to grab one of the hydrogens off of this and pull it onto itself. So what does that make on the other side? We're going to have H3O plus, that's aqueous, and we're going to have the remainder. Now again, take a look at this. If we remove just one hydrogen on this, won't we have left HCO3? But here's the thing, that HCO3, we just lost a plus. Wouldn't that be HCO3 minus? So we're going to take that and we're going to write on the other side and write HCO3 minus. Now, this is what's really interesting about polyatomic ions. And again, I would encourage you to watch the video on how we work with polyatomic ions. But if you notice here, this is the acid and this is its conjugate base. And the reality is that it could go backwards and this could react with water and reform this H2CO3. But then what we do is we take this here, what's the conjugate base, and that becomes the next step down here. So we're going to take this over here and we're going to start with our HCO3 minus AQ. We're again going to throw it into water. And we're again going to have the hydrogen here come off and attach to the H2O. So what do we end up with on the other side? We end up with H3O plus. And what's left over is going to be CO3. Now remember, HCO3 right here, it had a minus because it had an H plus with it. But if we remove that H plus, now we have two minuses right here. So we're going to write HCO3, 2 minus. Make sure you put the states of matter aqueous and aqueous. And we're going to say, why did you put these two extra rows in here for us? Because there was nothing that we actually had to write. Hopefully this has been helpful, and we'll see how we're going to manipulate these in some of the future problems.